Hi guys, so we're just going to go over a second example today on the chain rule. So remember the chain rule, you can kind of derive two things at the same time, but there's no rule for it. For example, like product or quotient rule. So in this case, we would implement the third variable known as u and derive with respect to that. Um, Notice in number 2, I changed everything to t instead of x. Keep in mind, you can replace t with x instead if you're more comfortable with just working with the same variable. But I'm trying to push those limits just a little bit and get you comfortable with t as well, because you will see them in the word problems a lot more since t is the independent variable known as time. So we're going to start off here with, what do I assign as u? Because technically 1 over this entire expression I could also derive the expression itself. So I know I need to apply the chain rule. So sidebar, I'm going to assign u as t squared plus 3t minus 1. So if I'm trying to find out what dy over du is, first, let me rewrite y in terms of u. So now this would be 1 over u. Notice I'm replacing the denominator with u, which is noted on the side here. So this would be a little easier for me to derive, but again, to begin with, this is u to the first power in the denominator. I'm not going to use the power rule until that's in the numerator. So in order to move it up to the numerator, I change the sign of the power to become -1. The 1 itself in the numerator, you could put it here if you want to, but we don't really see the coefficient 1 there. So if it makes you feel more comfortable, yes, you can put it there. Now to derive this, meaning to find the derivative of y with respect to u, I'm going to apply the power rule. -1 times 1 is -1, and I take 1 away from the power, which would give me -2. So I've got this part down, dy over du. Now I need to multiply it by du over dt. Well, what is du over dt? It is the derivative of u with respect to t. And here it is right here. The derivative of u with respect to t, using the power rule, I'm going to derive the u. This would give me 2t to the first power plus, again, the power for 3t is 1. 1 times 3 is 3, and I take 1 away from the power to give me t to the 0, which I don't need to write down, and the derivative of any constant is 0. So du over dt is just 2t plus 3. I'm going to put that in parentheses. 2t plus 3. So I have my dy over dt almost. I still have a variable. It's not in terms of t yet. So this needs to get replaced in order for that to happen. So I'm going to replace that u. Remember, sidebar, we assigned u, so we're going to just change it back now. U is equal to t squared plus 3t minus 1 to the -2nd power times 2t plus 3. This is actually the derivative, dy over dt, but now we just have to clean it up because, one, we're not going to leave a negative parenthesis or a negative exponent in the answer, and that's pretty much what I'm going to clean up here. So since the -2 belongs to everything in this parentheses, I am going to put that expression in the parentheses in the denominator to make the exponent positive. Everything else, though, I'm going to move over. So that -1 gets moved over. That 2t plus 3 gets moved over. And I would say this could be your final answer, or in the numerator, the -1 could be distributed, giving you -2t minus 3 over that denominator. And that could also be shown as your final answer. Again, since you have assignments that are multiple choice, I'm just showing you both ways that you could see it. All right, guys, I hope this helps.